Hello and welcome. My name is Chris Ellis, and in today's video I'm going to show you how to make a Bitcoin full node using a Raspberry Pi 2. So if you've been following me over the last few weeks, you'll have seen that I've been making these full nodes for the price of a Foxconn factory worker live on air. But in this video I wanted to make a high definition version for you, something that you could follow along easily. The live shows that we've done before have often gone on for like 8 hours at a time. It is a piece of art, but people have found it very, very difficult to follow along. Now, accompanying this video is a Git repo, a GitHub repo. You can get there by fullnode.protip.is, and that will forward you straight to the instructions which you can follow along, and I'll bring them up on screen as I go through. So let's run through some of the essentials that you will need. In order to do this, you will need a Raspberry Pi 2. It looks like this once it's unboxed. The Raspberry Pi 1, the original, probably won't be good enough. You'll need the version 2. You're going to need a micro SD card like this one, made by Kingston, preferably class 10 with wear protection. You can also use other reputable brands like SanDisk. You're going to need storage space on the full node because the Bitcoin blockchain is very large. We've been using these SanDisk cruisers, 128 gigabyte. That should last you about a year or so at the current block size. And you're also going to need one of these. This is a 2 amp 5 volt USB charger. They're fairly common. You're going to want the kind that can power tablets rather than phones. A phone charger for this project will suffice so long as you don't have lots of peripherals plugged in. So if you bought the full node off of me and all you plan to do is plug it in and have it running in the background and you're not going to plug it into a monitor or anything like that, then a phone charger will probably be good enough. But if you actually want to use the Raspberry Pi functionally all the time and use some of its extra features that we're going to put on there, you're going to need a tablet charger, 5 volt. Now, I also recommend good quality USB cables. I've been supplying with the full node these Anchor ones, 3 foot, 1 meter long USB cables. And the advantage of them is they're quite chunky and durable, and they provide good consistent current to the circuit board. The other thing you're going to need is an Ethernet cable so that you can plug it into your router at home and access it from your computer. Okay, so let's get started. I'm going to start with the Tontec case. Now, strictly speaking, you don't need one of these, but I find it helps a little bit. You can actually just use your fingers like so to unscrew the little caps at the top. Just remove one on each corner. Now, once you've actually got the Tontec case like this with the screws off the top, what you can do is just lift up the lid, and the first thing we're going to do is we're going to put the fan inside of the lid. So we're going to get one screw, go inside, turn it over, and we're just going to screw it on the finger again. No, strictly speaking, it's not necessary to use the tool to do this. You can just use your fingers. You might need to tune it up later because sometimes the nuts on your node can come loose. And also if the screws are not tight enough, sometimes the fan can vibrate somewhat loudly against the rest of the plastic. So sometimes a little bit of fine tuning is required. Okay. There we go. So that's all in. Now the next thing we're going to do, now that's ready, put that to one side, is we're going to want to put the actual Raspberry Pi inside of the Tontec case itself. So the easiest way to do this is to lift up the top platters, and then I find it's convenient just to turn them over like so, so that you're just left with the bottom two. And then the Raspberry Pi just slots in like so, just nests in there. And then what you can do, well, you can put them down one at a time if you like. And you'll see each layer clasps around the various components in the Pi itself. And I chose this design because I thought it was quite stylish. It looks really cool, it's very neat and tidy, and it protects the Pi from any kind of external threats that it might face in its life. So you can just have the Raspberry Pi bare, of course. Some people like to have their nodes nude. Now, when you put the fan in, look for the live wire, the red wire, and it needs to go into the slots here, just one to the left on the row farthest away from you. So with the Pi logo facing towards you, it is along the top row of the GPIO board, and the red is on the left, one in from the left. And we just push that down. And then we just put your finger underneath the cable, just wrap it round neatly. It's a little bit fiddly to do if you want to be a perfectionist like me. There we go. Now once that's in, you can now put the screws on top. Now, when you put all the screws on at the end, you might need to fine tune them a little bit just to stop the fan from vibrating. You don't want to screw them in too tight, because if you do, then the ports get blocked at the back for the keyboard and the memory stick. And so, yeah, don't do it too much. Just make sure that it's in fairly firmly. And there you have it. There's your Fullnode, ready to go. So the next thing we're going to do is we're going to format the micro SD card, and we're going to put on it the latest version of Raspbian Jessie. In this video, we're going to be using a Mac running OS X for our instructions, but there is a link in the description below for other operating systems. Okay, so now we're back. So go over to fullnode.protip.is, and that will bring you to my GitHub page where I've got the instructions for the Fullnode. You'll see a picture of the completed Fullnode here. And what we're going to do for the purposes of this demonstration is we're going to follow the setup guidelines for setup 1. So click on that link and it will start to take you through the process. So let's start with the first process, which is going to be installing the Raspbian disk image. So we're going to download the zip file of Raspbian Jessie, and we're going to save that. Okay, so once that's finished downloading, you're going to want to go to the downloads folder, and you're going to want to unzip it. Next thing you're going to want to do is you're going to want to load up the terminal, which you just go to Spotlight on the Mac and just do that. Now I'm already in the downloads folder, but actually you can just get there with the command change directory, downloads, just hit the tab key and it will auto complete. ls, and you can see we've got 2 files in there, Raspbian Jessie .img and the zip file. The one we're interested in is the img file. That's the disk image we're going to use, which we're going to burn to the micro SD card. Now I've just pulled up the instructions again so that we can actually go through this. I've inserted the micro SD card into the computer via the adapter. You can see it's showing up here on my desktop. And what we're going to do is we're going to run the command disk-util-list. And that's going to list our disks. Now in this case you can see that it's actually disk 3. In my instructions it's disk 2, and it will be different for you. as a general safety precaution, you should disconnect any hard drives or any media that have any sensitive information on them, so you don't accidentally do what we're about to do, which is wipe over the disk that we just inserted. You don't want to make a mistake in this next step. And that's because in this next step, we're going to be running a command called dd, which stands for data description, and sometimes colloquially known as disk destroyer. That's because it has the ability to destroy disks if you're not careful. So the next step, we are going to run disk util umount disk. Notice the uppercase D, it is case sensitive. And then we're going to be unmounting, in this case, disk 3, which is different to what was listed in my instructions. Now, the next step, we need to run admin privileges. So we're going to be running the command sudo dd, the disk destroyer, and then the input is going to be 2016. Now, one of the features of command line is to hit the tab key. So if you hit the tab key, it's going to auto-complete for you, and then you can just go just I, and then it will complete to img. Now, the output is going to be of equals, and actually you can just copy this in up to this point here with 3 in it, because we don't want to accidentally delete something. Now, the BS here stands for block size. So we want a block size on our boot disk of 4096K, or bytes, I should say. And we want to check for errors, and we want it to write to disk straight away, which is what the no error and sync mean. I'm going to add those in. It's going to ask for your highly entropic password, which you change frequently and do not use on other devices, do you? And now we play the waiting game. And there we have it, all done. Now you can actually cycle up through the previous commands with the up arrow and just go back to your umount disk and unmount the disk. And then what we're going to do now is go over to a computer with a monitor and keyboard and get the Raspberry Pi set up. Okay, so we've installed Raspberry and Jessie onto the SD card, and I am now going to take out the micro SD and I'm going to put it inside of the Fullnode, like so. Just goes into the front and just pings in like that, a little spring mount. I'm going to plug in the mouse and the keyboard, and I'm going to plug in the Ethernet, and I'm going to plug in the monitor. Sometimes it's a good idea to plug the monitor in first, because if you don't, then what can happen is that it will not load up on the screen when you first boot it up. So we're just going to plug that in there, like so, and then point the camera up. And now Raspberry and Jessie is now loading. Okay, so Jessie is now loaded up. So we're going to go to the menu and we're going to go Preferences, Raspberry Pi Configuration, and we're going to expand the file system. And we're also going to ask it to boot into the CLI command line interface when we next reboot. SSH is already enabled with Jessie. It's not the same as before with Wheezy. We're going to overclock it for what we're about to do, and we're going to take the GPU memory down to 16, which is the lowest it will let you do. You can also set the localization of your keyboard. I happen not to need to be able to do that because Raspberry Pi are a British company and I'm in Britain, and so it's already pre-configured, but you need to configure that for your own locality. So we're going to auto log in as Pi as well. So we're going to click OK, and it's going to say, do you want to reboot now? And we click yes. So one of the things that we need to do is we need to find out the IP address. So we're going to type in sudo ifconfig, and that's telling us that the IP address locally on the network is 192.168.0.2. So now I'm going to head over to my hipster machine and I'm going to load up the terminal, and I'm going to do something called SSH into the device. Okay, so now what I'm going to do is going to return back to the hipster machine again. And I'm going to go into, I'm just going to clear the terminal there. And I'm going to do a secure shell SSH pi at 192.168.0.2, which was the IP address that we logged in with before. And there you can see it's allowing us to go through. Now, if it's the first time that you've logged in, it will ask you if you want to be permanently linked to the key pair. You simply type in yes and hit return if it asks you that question. Now, I just want to illustrate something, which is that you can actually also do this another way. For example, we can avoid the step that we've just taken by running a program like an IP scanner, and there are other software packages like this which allow you to scan your local area network for all the devices. And as you can see here, we've got the Raspberry Pi right here, and we could have found out the IP address this way. And an alternative to doing what we did would have been to go sudo raspberry config, having found out its IP address from that application, and then all the options here are the same as the options that we got within the GUI, right? So we can go to like advanced options here. We can look at the memory split. Now I've set the memory split now to 0, because in the command line you can actually do that. You can't do that in the desktop interface that we were just in. So I've set the memory split to 0, so no memory will be allocated to the GPU, to the graphical processor. And the reason is because what we're about to do doesn't require any graphics. What we're about to do is to install Bitcoin, so we don't need to be running any graphics. We're going to be remote accessing into that. Another fun thing you can do is you can go to advanced options and you can click on hostname, and you can call your node whatever you want. You can call it Fullnode, so that when you log in, you don't have to know the IP address. You simply type in pi at fullnode.local, for example. That's what you choose to call it. I'm going to choose to exit without doing anything because I'm happy with this configuration. So let's start off by going through what the instructions are. So we're up to here. We want to do an sudo apt get update. Now this is a very recent edition of Raspberry and Jessie, so I doubt there will be any updates because it's only been released very recently. Okay, now that's done. And so next we need to do sudo apt get, which is the package manager, and then we're going to do upgrade, and then the Y flag at the end just says yes. That basically means whenever it asks you a question of yes or no, it's going to answer yes by default. Okay, now that's finished. The next thing we need to do is install the dependencies, and this is just for Bitcoin D, not for the whole GUI. So we're just going to copy and paste that into the command line. Now the Y flag at the end again denotes that it's going to say yes to all of them. Now, next what we have to do is install the dependencies for the GUI, for Bitcoin Qt. If you want to skip this step and you have no intention of running Bitcoin Qt and you just want to run it headlessly, you can and skip this step. But we, for the purposes of this demonstration, will be running it. Okay, so that's finished. So before we go ahead and start installing Bitcoin, what we're going to do is we're going to increase the swap file size. Now, this is really only necessary if you don't have a lot of space left. You can run the command df with the flag h, and you can see that I have quite a bit of disk space left, 3.1 gig available, so that's more than enough. So you have to have at least 2 gigabytes free, because we're going to increase it by quite an amount. And this is just so that whilst Bitcoin is compiling and installing, that it has enough memory that it can run. And if there's an overrun, it can just put it onto the SD card instead of storing it in the RAM chip on the processor. On the motherboard. So we've changed the comp file swap over to 1024 by opening up the text editor Nano and editing it. Check the setup, 1024. Okay, and that's done. Took a little while, but we got there. Now what we're going to do is we're going to create a folder where we're going to actually put our binary files. So we're going to create a little tilde there, -bin, creates a folder in the home folder called bin, and then we're going to cd into the bin folder. So if we do pwd now, you can see that we're in home pi bin, stands for binary. Now we're going to install the Berkeley DB, Berkeley database. So we're just going to download that tarball, which is like a zip file, so it's like a compressed file, more commonly used in Linux than it is in other operating systems. And then we're going to untar it, unzip it. And then we're going to change directory, and we're going to go into the build folder. And now we're going to configure it. Okay, and now that's done. I'm going to just create a bit more room on the screen because we're about to compile Bitcoin. I want to make it nice and big. So we're just going to actually first of all make the Berkeley DB database, and the J4 flag here instructs the Pi to use all 4 cores of its processor. Okay, this part is done, and now we just need to do the installation where we place all the files into the various parts of the operating system ready to be run. And now we're ready to get on with the business of installing Bitcoin version 0.12. So we're going to cd or change directory back into the binary folder from where we started. And this time we're going to use git to clone the branch, the B flag there, 0.12, and it's going to generate a folder inside of the binary folder called Bitcoin. This part doesn't take very long. Okay, that's done. Now we're going to cd into the Bitcoin folder, and then we're going to do autogen.sh. It's a bash script, self-executing bash script. It's going to prepare some of the files for us that the Bitcoin developers have already pre-prepared. This part is a little bit slow at the beginning. It takes a little while to get going. Okay, so the autogen is complete. Now we need to configure. Now this part is particularly tricky. We're going to configure with the Berkeley flags, but we're going to be enabling UPnP, which allows us to punch through some of the firewalls that are pre-enabled on routers across the world. It apparently only works on around 20% of routers. For those that it does not work on, you will need to go into your internet service provider's router, like your Virgin Media or whatever, your AT&T, and you're going to need to configure the settings for port forwarding on port number 8333. And you need to usually find that under advanced settings and then port forwarding, but where possible, universal plug and play UPnP should be enabled. And then we're also going to say that we want to configure it with the GUI, the graphical user interface, equals Qt4. So I'm just going to copy that line out because it's quite a long line, paste that into the terminal, and hit return. Now that that's done, we can actually get to the business of making Bitcoin. So we're going to run the command make. Now J2 instructs the Raspberry Pi to use 2 of the cores. Now this can cause problems, and sometimes you can get errors. This process can take between 2.5 and 5 hours. This is by far the longest part of the process, so you will need to go away and do something else whilst this is going on. But if you do find that it completes sooner than it should have, then by all means just run it with the make command only. I made that clear here. You can just use the make command on its own, but it will take a lot longer, something like 5 hours on the Raspberry Pi 2 Model B. So let's try our luck with J2 and see how we get on. Okay, and that's all done. That took about a total of 2.5 hours or so. So it seems to have worked fine. And so we're going to now run the final command, sudo make install. Which itself takes a little bit of time, but not anywhere near as long as the previous one. And there, that's finished. Now, if you want to, you can actually delete the binary folder that we created. We can just run this command right here. And that will just free up some space for you because we don't need those anymore. Now, in the next section, we're going to discuss installing the blockchain itself and establishing the home folder for the blockchain where the Bitcoin data is going to be stored. So what you now need to do is take whatever media you prefer. We had a SanDisk Cruiser earlier on, as you saw, but you can also use an external hard drive or an SSD drive, anything that will be big enough. At the moment, the blockchain at the time of making this video is around 66 gigabytes. So you'll need probably 128 gigabytes or larger disk drive, preferably a dedicated drive that is specifically for that purpose. Now, I'm just going to clear, and I'm just going to go back to the home folder just because it's nice and clean that way. And the next thing we're going to do, assuming that you're using an external drive and not one that's big enough internally, is we're going to, let's first of all make the .bitcoin folder, which is where we're going to be storing the Bitcoin data. So if I go ls-la, you will now see a .bitcoin folder. The LA flag lists all the files in that directory, even if they're hidden. And the next thing we're going to do is run this command here, blkid, which is going to list all the information about block devices attached to the media. So you can see that we have SDA1 here, a drive called SDA1, and that is likely to be external media. That's usually how they're named. And what we want to do is we want to format that into FAT32. So I'm going to take this command here, make fs vfat, which stands for FAT32, format the external drive, that's the SanDisk Cruiser, and then I'm going to get the new UUID number, unique identifier number of that drive, which is 0B16, etc. So I'm just going to copy that to the clipboard, and then I'm going to edit a file called fstab, file system table, I believe it stands for. And I'm going to, well, I just need to keep a copy of this one, and then I need to, because I can't remember off the top of my head, all of these settings. So we're going to copy into this file a list of drives that are going to be mounted automatically on boot. And we need to tell the machine to boot according to the unique identifier, because sometimes the actual drive name can change depending on whether you've attached other media and what order it gets loaded up in. Now, it's basically saying find this UUID number and then mount it to this mount point. And we're going to be mounting the USB drive to the home folder .bitcoin, which is where the Bitcoin application will look for the blockchain data. We're telling it that the file format, the file system, is going to be VFAT or FAT32, that the user ID is Pi, that the permissions on that drive will be, that's what UMask means, the permission of, as you write the files will be set accordingly. We're going to write directly to disk. That actually does slow things down somewhat, but it's more efficient. It leads to less data corruption. And there are some other sort of details in there that I think are beyond the scope of this video. So let me just get on with that. Put this in here, and then just copy that UUID number into there. Control X, then Y, and then return. And then I'm out of that folder. And then I'm just going to reboot the device. Now, you'll need to wait a certain amount of time for the device to reboot. I'm just going to clear the screen, and we're going to do the SSH secure shell command like we did before. And it's 192.168.0.2. Default password for the Pi is raspberry. You should probably change that. And so we're going to just change directory into the .bitcoin folder. You don't have to use the whole path. You can use relative path because you're already in the home folder by default. Just do a little ls. Obviously there's nothing in there at the moment, but we're going to start off just by creating a conf file. And we're just going to list some basic arguments in here. So we're just going to put in listen1, which means you're going to listen on the network. So you're going to be serving out blockchain data. You're acting as a server, and you don't want the testnet, and you do want the daemon to be enabled. There are other parameters, and we've talked about those in other videos, and we can refer to those in other documents as well. But that will suffice for now. Control X, then Y, and return. And then all we have to do now is start the Bitcoin daemon, Bitcoin D dash daemon. Bitcoin server is starting. Now you want to Bitcoin. Remember, you can hit the tab key to autocomplete. Get info. Now you're likely to get an error message like this one. That's perfectly okay. Just means it's loading up the blocks. If we go ls now, you'll see that it's populated and bootstrapped with a wallet file, a database file, a chain state data, also a debug log file, which is going to contain a lot of information about all of the peers that you're connected to and all of that sort of information. And you'll use that for debugging, and straight away there we are, we're downloading the blockchain. So we're running version 12, it says there. and we are 447 blocks in already, and we've only just started. So that's it. That's enough, I think, for this tutorial. I'll go into other videos. I'll discuss about how, opening up in Qt, and also we have other tutorials that you can check out in the setup guides. Just go to fullnode.protip.is and you will see, for example, how to set up a lightweight headless full node, how to strip down Jessie and take away some of the excess applications that you probably won't need on your full node, and also how to install all the extras like the Iceweasel browser, how to install Tor, OpenVPN and the Resolve configuration, Node.js, IPFS, which is actually one of the most exciting projects in this space right now. So stay tuned for that, and please, if you do find any errors or mistakes in this video, do give me a shout out. You can put in pull requests, they are more than welcome. You can also join us on the Gitter chat room where we will be hanging out, and it's free open source software that you can use to collaborate on, and anyone can then teach each other how to make progress in this space. So thank you very much for your time. Best of luck. Reach out if you need anything. Bye bye.